Your brake pads still have 6 millimeters of life left. The rotors are perfectly smooth. And yet every single time you slow down, your car screams like a dying cat. You take it to the dealer. They hand you a $400 estimate for new pads and rotors. You pay it. 3 weeks later, the squeak is back. Sound familiar? Here's what the dealer will never tell you. That squeak? In the majority of cases, it has absolutely nothing to do with worn pads. German automotive engineers have known this for decades. And Porsche, BMW, and Mercedes dealerships in Germany actually follow a specific diagnostic and correction protocol before they ever touch a single brake component. It's a method almost no American mechanic uses, which means most American car owners keep paying for parts they don't need. Today, I'm walking you through the full German method, step by step, so you can do this at home with tools you probably already own. Fix the squeak for good, and never get upsold on an unnecessary brake job again. But first, let's talk about why brakes squeak in the first place. Because if you don't understand the root cause, you'll get this wrong. Why your brakes are screaming. Brake squeal is a vibration problem, not a wear problem. When your brake pad presses against the rotor, that contact creates friction. That friction generates heat. And under certain conditions, that system starts vibrating at a specific frequency, typically between 1,000 and 16,000 hertz. And that vibration is exactly what you hear as a squeak or squeal. Modern brake systems are precision engineered to avoid this resonance, but several real-world factors knock them out of spec. Glazing is the big one. When brakes are heated and then cooled repeatedly without ever reaching their proper operating temperature, a hard, glassy layer forms on both the pad surface and the rotor. Glazed surfaces don't grip the way they're designed to. Instead of smooth friction, you get micro-vibrations, and those micro-vibrations become squeals. This is incredibly common in city driving where you never really push the brakes hard enough to fully bed the system. Corrosion is next. Rotors are iron. Iron rusts. After one rainy night or even just morning dew, a thin layer of surface rust forms on your rotors. That's normal, and under normal braking it wears right off. But if it builds up unevenly, or if the rust gets trapped between the pad and rotor, you get noise and vibration. And then there are the contact points. Every brake pad has metal clips, shims, and ears that contact the caliper bracket. If those points are corroded, dry, or contaminated, the pad can't float freely. A pad that can't move freely vibrates. A pad that vibrates squeaks. This is what the German method targets. Not the pad, not the rotor, the system, what you'll need. Before we get into it, gather your materials. You need a quality brake cleaner spray, a wire brush, 120 grit sandpaper, a can of copper-based anti-seize compound, or dedicated brake lubricant, nitrile gloves, and a jack with jack stands. Total cost if you're buying everything from scratch, under $25. Compare that to a $400 brake job you didn't need. Step 1. The inspection that changes everything. Jack the car up safely and remove the wheel. Now, look at the pad before you touch anything. German protocol starts with a proper measurement. You need a brake pad thickness gauge, or even a simple ruler. If your pad has more than 3 millimeters of friction material remaining, the squeak almost certainly is not a wear issue. Most pads have a wear indicator that starts squealing at around 2 millimeters, to warn you they are due for replacement. If you are hearing noise at 5 millimeters, 6 millimeters, or more, your pad is fine. The system has a different problem, and replacing the pad will not fix it. Now, look at the rotor surface. Run your fingernail across it. If you feel a ridge, a deep groove, or if it looks shiny and mirror smooth like glass, that is glazing. Remember what I said about glazed surfaces? They vibrate. We will fix that in a moment. Check the rotor edges. See that lip of raised metal around the outside? That is normal buildup. But if it is sharp enough to cut you, and more than about 1.5 millimeters raised above the surface, your rotor has worn unevenly, and this method alone will not solve it. Step 2. The cleaning protocol. This is where most American mechanics skip two of the most important steps. Spray. Brake cleaner generously on the entire rotor surface, both sides. Do not wipe it. Let it dry completely. Brake cleaner is designed to flash off, and it lifts contamination with it. That includes oil residue, compacted brake dust, and any surface contamination that interferes with proper pad contact. Now, take your wire brush and go to work on the caliper bracket. That is the fixed metal part that the pad slides in and out of. Clean every surface, every channel, every corner. You will find a combination of rust, old grease, and compacted brake dust in there. All of it is contributing to your squeak. Get it all out. This step alone fixes squeaky brakes on a significant percentage of vehicles, because a contaminated caliper bracket forces the pad to sit crooked and vibrate against the rotor. Step 3. Address the glaze. If your rotor surface looked shiny or glass smooth when you inspected it, tear off a piece of 120 grit sandpaper and sand the rotor surface in a crosshatch pattern. Not along the direction of rotation, crosshatch. You are not trying to machine the rotor or remove significant material. You are scuffing the surface just enough to break up that glazed layer and give the pad a proper mechanical surface to grip. This takes about 90 seconds per rotor. Wipe it down again with brake cleaner when you are done. Do the same to the pad face if it also looks glazed, shiny, or has a hard polished appearance. Lightly scuff the face of the pad with sandpaper, then chamfer the edges. Chamfering means taking the sandpaper at a 45-degree angle and knocking the sharp corners off the leading and trailing edges of the pad face. BMW and Porsche factory technicians do this on every new pad installation before it goes anywhere near a caliper. It changes how the pad makes initial contact with the rotor during braking and dramatically reduces the chance of high-frequency vibration. It takes 30 seconds, and it is something almost no American shop does by default. Before we finish the last two steps, quick favor. If you've learned something here that your mechanic has never told you, hit that like button. It genuinely helps this channel reach more people who are getting overcharged every day. Step 4. The lubrication points. This is the most critical step in the entire German method, and it is the one most likely to be done completely wrong or skipped entirely. Get your copper anti-seize or brake-specific lubricant ready. Listen carefully, because this part matters. Do not put lubricant anywhere near the pad face or the rotor surface. None. Not even a little. Lubricant on the friction surfaces destroys your braking performance and creates an entirely new set of problems. You are lubricating only the metal-to-metal contact points. Apply a thin layer to the back of the brake pad, specifically where the pad contacts the caliper piston. Apply it to the caliper bracket slide pins, the two threaded bolts that allow the caliper to float back and forth. If those pins are seized or moving stiffly, your caliper cannot release properly after each brake application. That leads to constant light contact between pad and rotor, which leads to heat, which leads to glaze, which leads to squeak. The Germans call this a floating caliper failure, and it is one of the most overlooked causes of brake noise in the industry. Finally, apply that thin layer to the contact ears of the brake pad, the small tabs on either side that slide in the caliper bracket channels you just cleaned. This is the key. A pad that can slide freely, float freely, and release cleanly after each application will not vibrate. A pad that cannot, will. Step 5. The bedding procedure. Here's the part nobody tells you about, and it's the reason why even perfectly installed brakes can still squeak if this step is skipped. Bedding is a controlled heat cycling process. It transfers a uniform layer of brake pad material onto the rotor surface, which gives the system optimal bite, minimizes vibration, and eliminates residual glazing that your sandpaper did not fully remove. German performance car owners know this instinctively. Every time you put a fresh set of pads on a Porsche, The factory manual specifically instructs a bedding procedure. It works just as well on a Honda Civic or a Ford F-150 with an existing set of pads that were just cleaned and deglazed. Find a safe, open road or a quiet stretch of highway. Bring the car up to 30 miles per hour and apply moderate, steady brake pressure to slow down to about 5 miles per hour. Do not stop completely. Roll forward slowly, let the brakes cool for 30 seconds, then repeat from 30 miles per hour. Do this 6 to 8 times, then bring the speed up to 50 miles per hour and do the same sequence 4 to 5 times. Moderate controlled pressure, slow to 5 miles per hour. Roll forward, cool, repeat. You will start to smell a faint burning smell. That is completely normal. That is the brake material transferring to the rotor. That smell is your brakes bedding in properly, probably for the first time since they were installed. After the bedding runs, drive normally without hard braking for at least 10 minutes to let the system cool. Do not park immediately. Keep rolling. When this won't work, and what that means. The German method solves noise caused by glazing, contamination, dry contact points, and improper bedding. That covers the vast majority of brake squeaks. But there are situations where it will not fix the problem, and you need to know the difference so you are not wasting time. If your pad has less than 3 millimeters of remaining friction material, replace it. That wear indicator is doing its job. If your rotor has a raised lip at the edge exceeding 1.5 millimeters, or if you can feel deep grooves when you drag your fingernail across the surface, the rotor is beyond what surface preparation can fix, and it needs to be replaced or machined. If the squeak comes with a grinding metal-on-metal sound rather than a clean squeal, that is a different situation entirely, and it means pad-to-rotor contact that needs immediate professional attention. And if the squeak happens only when you first start driving but disappears after 1 or 2 stops, that is almost always just overnight surface rust burning off, and it is completely normal behavior, not a problem at all. The real takeaway: brake shops in America are built on volume. The faster they turn a car around, the more money they make. Spending 20 minutes cleaning contact points and properly lubricating a caliper bracket is not profitable when they can just swap the pads in 10 minutes and charge you $400. That is not a conspiracy, it is just business. But it is your money, and now you have the information. A trained German automotive technician looks at a squeaky brake system as a system, not just a pad and rotor swap waiting to happen. They measure, they clean, they lubricate the correct points, they chamfer the pad, and they verify with a proper bedding cycle. That is the method. It takes about an hour on a Saturday morning, costs under $25 in materials, and it genuinely works. If you found this useful, hit that subscribe button and the bell so you get the next video the moment it drops. We go deep on car maintenance topics that save you real money, and we do not sugarcoat anything. Thanks for watching. See you in the next one.